Hi everyone, myself Vasant Reddy from Sri Venkateshwara College of Engineering, branch CSEI. In this video, I would like to give a small presentation on Eden Markov model. Coming to the introduction of Eden Markov model, it is a statistical model that is used to describe the probabilistic relationship between a sequence of observations and a sequence of hidden states. It is often used in situations where the underlying system or process that generates the observations is unknown or hidden. Hence, it got the name as Hidden Markov model. It is used to predict the future observations or classify sequences based on the underlying hidden process that generates the data. An HMM consists of two types of variables, hidden states and observations. The hidden states are the underlying variables that generate the observed data, but they are not directly observable. And the observations are the variables that are measured and observed. Coming to the applications of hidden Markov model, online handwriting recognition, speech recognition, gesture recognition, motion video analysis and tracking, stock price prediction, optical signal detection, digital communications, music analysis, and DNA sequence analysis. Uh, Prediction of the weather for the next day based on the current day's weather using the hidden Markov model. The code imports the NumPy, Matplotlib, Seaborn, and the HMM learn libraries. Firstly, we are going to import the necessary libraries that are the NumPy, Matplotlib, Seaborn, and HMM learn libraries. Import NumPy as NP and import matplotlib.pyplot as PLT. Import Seaborn as SNS, and finally from HMM learn import HMM. The start probabilities, transition probabilities, and emission probabilities are defined as arrays. The start probabilities represented the probabilities of starting in each of the hidden states. The transition probabilities represented the probabilities of the transitioning from one hidden state to the another, and the emission probabilities represented the probabilities of observing each of the outputs given a hidden state. The initial state distribution is defined as the state probability, which is an array of probabilities that represented the probability of the first state being sunny or rainy. The state transition probabilities are defined as transition probability, which is a 2 into 2 array representing the probability of transitioning from one state to the another. The observation likelihoods are defined as emission probability, which is a 2 into 2 array representing the probability of generating each observation from each state. Uh, Now starting, define the initial state distribution. State probability equals to np dot array 0.6 comma 0.4. Print the state probability comma state probability. And the next one, define the state transition probability. Transition probability equals to np dot array 0.7 comma 0.3, and the next one is 0.3 comma 0.7. It is a 2 cross 2 matrix. And then finally print transition probability. And finally the define the observation likelihoods. Emission probability equals to np dot array 0.9 comma 0.1, and the next one is 0.2 comma 0.8. Even emission probability is a 2 cross 2 matrix. Print the emission probability comma emission probability. Coming to the output, state probability is equals to 0.6 comma 0.4. Transition probability is 0.7 0.3 and 0.3 0.7. And finally the emission probability is 0.9 0.1 0.2 and zero point 0.8. Define an observation sequence. A sequence of observations is defined as a 1D NumPy array. The observed data is defined as observation sequence, which is a sequence of integers. representing the corresponding observation in the observation list. Decode the observation sequence. The Viterbi algorithm is used to calculate the most likely sequence of hidden states that generated the observations using the decode method of the model. The method returns the log probability of the most likely sequence of hidden states and sequence of hidden states itself. Log probability hidden states equals to model dot decode observation sequence length equals to length of observation sequence. Algorithm is Viterbi. Print log probability comma log probability. Print the most likely hidden states comma hidden states. Coming to the output, log probability equals to point minus 6.360 and so on. Most likely hidden states are 0, 1, 1, 1, 0, 0. Plot the results. Now, plotting the results. SNS dot set style white grid plt dot plot hidden states, that is minus 0 label equals to hidden state plt dot x label time step plt dot y label most likely hidden state plt dot title sunny or rainy plt dot legend plt dot show. And this is the white grid of sunny or rainy. This is in the x-axis we are taking the time step, and in the y-axis we are taking the most likely hidden states. And this is the white grid of sunny or rainy output.